Okay, so in this video, we're going to have a look at how to find limits of accuracy. The limits of accuracy tell you what the upper and lower boundaries are for the true measurement. That's because all measurements are never truly accurate. So it could be a little bit bigger or a little bit smaller than what we have measured. Usually, it is plus or minus 0.5 times the smallest unit of measurement. For example, when measuring to the nearest centimeter, 86 centimeters has limits of 85.5 centimeters up to, but not including, 86.5 centimeters. Anything in this zone would be 86 centimeters to the nearest centimeter. So let's have a look at some examples. Give the limits of accuracy for these measurements. So question A, we have 72 centimeters. In order to work out or determine the smallest unit, we look at the last digit in the measurement, make that a 1, and all other digits become 0. So here, the smallest unit is 1 centimeter. To find the lower bound, we do half of that 1 centimeter. Actually, let's do it like this. We take the measurement and we minus half of the smallest unit of that 1 centimeter. When we put that in the calculator, what do we get? 72 minus half times 1, 71.5 centimeters. The upper bound is exactly the same, but instead of minus, we're plussing half times the smallest unit. Put that in the calculator and you get an answer of 72.5 centimeters. That means the limits of accuracy is 71.5 to 72.5 centimeters. Okay, that's a range, not a minus sign. In question B, we have 86.6 millimeters. So we're going to look at the last digit, turn that into a 1. That means all the other numbers become 0. So technically, the smallest unit is 0.1 millimeters. Therefore, the lower bound is the measurement, 86.6 minus half times that smallest unit of 0.1. Let's put that in the calculator. $86.55 millimeters. To work out the upper bound, we take the measurement, 86.6, and we add half times 0.1. Put that in the calculator, and we get an answer of 86.65 millimeters. Therefore, the limits of accuracy are between 86.55 and 86.65 millimeters. Now you might be starting to notice a pattern. I always find it easier to work out the upper bound first. So let me just get rid of all this. If we have a look at the measurement, 72 centimeters, the upper bound is 72.5 centimeters. Let's have a look at B. 86.6, the upper bound is 86.65. Technically, all we're doing is we're adding another digit of 5. So in question A, we have 2 digits becomes 3. Question B, we have 3 digits become 4. Okay, to find the upper bound, we're just adding an extra digit to the measurement of a 5. Okay, whatever's next in line. So I work out the upper bound first. To work out the lower bound from that, I take the second last digit and minus 1 from that. So in question A, 72.5 minus the 1 from the 2 becomes 71.5. Question B, 86.65, the second last digit is 6 minus 1 from that is 5. So the answer for the lower bound is 86.55. So I'm going to apply this to question C without even finding the smallest unit. So I have my measurement of 43.92. So my upper bound is going to be 43.92, but I'm going to add a 5 kilograms. To find my lower bound, I'm going to take that second last digit and minus 1 from it. So my lower bound is going to be 43.915 kilograms. Okay, so that's the shortcut method where you don't need to find the smallest unit, which in this case is 0.01 kilograms. Okay, that becomes a 1. All the rest become zeros. But instead of doing measurement plus or minus half of the smallest unit, I can get straight to my answer by doing that shortcut. Therefore, the limits of accuracy are 43.915 to 43.925 kilograms. Question D, I'm going to do the same thing. I'm going to start with my measurement 15.060 for the upper bound, but I'm going to add a 5 liters. I'm going to take my second last digit and minus 1. But you see here how it says 60, because it's hard to take 1 away from 0, so it's like 60. I'm going to have 15.0, 60 minus 1 is 59, and I write my 5 liters. Therefore, the limits of accuracy are 15.0595 to 15.0605 liters. If you want to know what the smallest unit is, we take that last digit and make it a 1. The rest turn into zeros. So it's 0.001 liters. Let's apply this to this next question. Janice measures each side of a square as 6 centimeters. Find the upper and lower limits for the sides of the square. So question A. The upper limit, because I find that easiest to do, is 6.5. Okay, just adding another digit. The lower limit, take the second last digit, which is the 6, minus 1 is 5. So we have 5.5 centimeters. That's the upper and lower limits of the sides of the square. So question B requires us to find the upper and lower limits for the perimeter of the square. Well, here's our square. If it is actually 5.5 centimeters all around, then the perimeter, the lower limit for the perimeter is going to be 5.5 times 4. But what if the square was actually, if the sides were actually 6.5 centimeters long? Then the upper limit of the perimeter is 6.5 times 4, which is 26 centimeters. Question C. The upper and lower limits for the square's area. Well, if the square, again, is 5.5 by 5.5, the lower limit for the area of the square is 5.5 squared 5.5 times 5.5. 30.25. That's the smallest the area of the square would probably be. The upper limit of the area would be, well, what if it was 6.5 by 6.5? 42.25. Okay, that's the largest the area of the square would be. And that's it for this video.